Gas tungsten arc welding (GTAW), also known as tungsten inert gas welding or TIG, and heliarc welding when helium is used, is an arc welding process that uses a non-consumable tungsten electrode to produce the weld. The weld area and electrode are protected from oxidation or other atmospheric contamination by an inert shielding gas, argon or helium. A filler metal is normally used, though some welds, known as autogenous welds or fusion welds, do not require it. A constant current welding power supply produces electrical energy, which is conducted across the arc through a column of highly ionized gas and metal vapors known as a plasma. Tungsten arc welding. The process grants the operator greater control over the weld than competing processes such as shielded metal arc welding and gas metal arc welding, allowing stronger, higher quality welds. However, TIG welding is comparatively more complex and difficult to master, and furthermore, it is significantly slower than most other welding techniques. TAG welding, short for tungsten argon gas welding, was the name given in the early 1970s to the then novel and revolutionary method of rod welding previously problematic metals. TAG welding was then the use of a tungsten-tipped, arc-creating welding machine. The tip was centered in a shroud that fed argon gas around the tungsten tip to prevent the composition of the weld becoming oxidized and fragile. TAG welding used rods of a metal suitable for the material to be welded permanently together. The rods could be a metal coated in oil to prevent the rod oxidizing if needed, or in more complicated welding of metals the rod would be coated in a flux that was not an active flux but a method of protecting the welding rods from oxidization during storage. The major examples of this were rods for welding, pure aluminium, duralumin, magnesium, aluminium alloy and stainless steel rods used for repairing ultra-high-grade carbon steel as in WW2 Sherman tanks. At this time the most prevalent use of TAG welding is in the production of higher-end aluminium alloy bicycles. These welds are clearly visible as ripples in the welded joint. Other than mostly bicycle production, TAG has been surpassed by the use of tungsten alloy tips and argon gas combined with other inert gases. TAG welding rods are now highly specific project metal alloy rods are more frequently mass production flexible, flux, cable, wire-fed drum machines. These developments have rendered the TAG name as not specific and have fallen out of favor, although the basic process remains the same. TIG welding is most commonly used to weld thin sections of stainless steel and non-ferrous metals such as aluminium, magnesium, and copper alloys. A related process, plasma arc welding, uses a slightly different welding torch to create a more focused welding arc and as a result is often automated.